Hello there, today we'll be doing majority element. This is a problem that we'll be doing using UMPIRE method. So first we'll understand the problem. So first of all, we are given a set of numbers and we need to find out which number is going to be a majority, and there will always be a majority number. In this case it is 3. It is over 50% of all the numbers. And in example 2, we see that there are like 1s and 2s, and 2 is the majority number. Okay, so we're going to ask some constraint questions. The constraint question is, well, like, what type of numbers are there? Like, and the answer is 1 to about 50k. So it could be a number between 1 and 50k. All right, and well, there could be between 1 and 50k different indexes of numbers, and the number can be between negative like a billion to about between and 1 billion. Okay, so what we're looking at is that we're looking to these are some understandings that we can have. Okay, so let's match, or let's think about different ways we can solve this. And different ways we can solve this is, one, we could sort and then count until 50% and return that number. That's one possibility. The other possibility is going to be using a hash set. Well, a set. In essence, we will store all the numbers inside the set and count the number of times it has been seen. With that, we will be able to find which element will cross that threshold first, and then, with that being the case, we will return that answer. With the set, we have an O of n time, and regarding the number, the space required, I would say it is going to be 50k. Well, actually 25k, because there's only going to be 50,000 numbers possible. So that's our constraint. We know for sure that we have an O of 1 possibility, like 25 different possible numbers, because there has to be a number, well, actually 2499, because there has to be a number that occurs 25,001 time, and that's the amount of times that we will need to store different types of numbers that we might need to store. But without that constraint, it's going to be O of n, because of the variety of numbers we need to store, which is n divided by 2, basically, minus 1. Okay, so it's essentially O of n space. However, we could sacrifice space for time if we do a sort. That way, we could just count a specific number until we switch to another number, and it does not it goes over 50% or not. We just throw that away and we just try a different number. So with the match, we'll be using a hash set. Okay. So for a plan, what we're going to do is iterate through the set of numbers and create a counter of each element until one element is 50%. Or greater than n, divided by 2. Okay, I think that's the plan. We're gonna implement it now. Alright, pretty easy implementation here. So for n in nums, for a number in nums, what are we gonna do? We're gonna count each item. There are several easy ways to do this, which is to use a counter. So counter equals counter of nums, and for number in for value, for a count in counter dot values, if count greater than n divided by, well, length of nums divided by 2 minus 1. Well, of course, we have to do parentheses around this. Then return that count. Return. Oh shoot. Num. I don't recall what it is to get both values of the counter. Let me just look that up. Counter Python loop so number in counter dot items. Yes, that's the word. That's the word. Okay. So it's dot items. Too bad there is no documentation when you click on this. Well, anyways, we have the num, we have the count. If the count is greater than this number, then return the num. And that should be good. That should be all the code that we need. And for review, let's test out some pseudocode. And that would be to run this function, majority elements. And we count one item. We count, so basically what this creates is a dictionary like item. So we have 3 and we have counted one time, and then we have a 2 and we count it one time, and then we counted 3 third time right here. So input, let me just make that more clear by pasting this here. So now we count it. So we have a counter, it just goes through these items at n speed, and now we count this as 2, and so we see that this is over 50%, which is, I mean, there's only 3 numbers, which is 1.5, and so this is over 1.5, and so that means we can return 3, which is good. Okay, so that's for review. That's done, and now let's evaluate. And as I said earlier, it's going to be because of these reasons above. It's going to cost us O of n time and O of n space. The reasons were that because we have to go through all the items, and there would be there's a possibility of 25,000 different items that do not add up to our solution, and we will need to be storing it all. So we divide by 2 items, but there might be a possibility of removing items once we see a certain threshold, but that's some optimizations that we can make. So let's run the code and see where we should be. It should be fine. All right, it looks like everything went well. Let's paste it here to the top and submit the answer. Uh-oh. So we outputted 6 instead of 5. It is not expected. Let's check that out to see what's going on there. That is unusual. So okay. I think that -1 was the problem because it went under 1.5, so greater than or equal to under code. I think this works a lot better this time around. So let's run some example cases and submit. All right, great. With that, we have solved the problem in about a few lines of code. Something that your interviewer might not like is the use of the counter collections type thing. We could implement it with a regular dictionary or default dictionary. Of course, it will cost a couple more lines of code. Let me show you how that's done. So counter equals default dict, and that's going to take in an int. So for num in nums, counter at num plus equals 1. So that's basically the same code, and but like more drawn out. So it still works. It looks like it's a bit slower as well. So now this is the slowest way of doing it without any assistance of the collections module. So let's by module I mean you have to import that collection module, but it's imported here. Okay, so what's next is we could do counter equals a dictionary, and we have to check if num in counter then plus equals 1. Otherwise, what we're gonna do, we'll have to say else counter at num equals 1. That's how we're gonna do it, and that also works. So let's submit that. Great, and so we have seen 3 ways of doing this, and we also have seen that the fastest way to do this is to use the counter collection, because I think it's optimized. Oh, it's actually, they're all the same now. Well, with that, we have solved the problem called majority elements, and I hope you enjoyed this video. If you do, like and subscribe. Want more videos, check the link in the description below, and if you have any questions, comment. Thank you very much, and I'll see you in the next one.